Okay, hello everyone, it's Salar and we are in part 30 of our tutorial, the tutorial to writing a real-time operating system. In previous part, I talked about global variable and how your compiler and linker allocate a memory to your global variable. As you know before, you have your local variables in your stack frame, but you have your global variables in that data section, and your linker should do relocation to allocate a memory to your global variable. You know what is relocation from previous part, but in this part I want to give you more information about linking stages and global variables and function relocation. Okay, a bit more information about linking stage. But as I said, we have that data section in our object file, but we have some more sections in object file, .bss and .rodata and other sections. Okay, but which variable is related to which function, which section? Okay, I want to give you more information about variable and sections. Okay, for example, as you know, initialized global variable like int var equal to 10, it has a value, it's initialized. Okay, has been located in that data section, but I want to give you more information about other types of variables. Okay, let's to give you an example. Okay, in this directory I have a project like previous part, and in my project I have a C file. In my C file I have some defined variable in my project, in my source file. Okay, for example, an integer global initialized variable, an static global variable, a constant variable by constant keyword, a zero initialized variable, initialized to 0, the value of variable is 0, the initial value is 0, an uninitialized variable, the variable has no value, and local variable and static local variable. Okay, let's build this project and see the object file. Open in terminal, make clean and make the project. Okay, let's see the object file of the main source file with arm object dash capital the option and name of object file. Okay, as you can see, I have a text section. I have a text section for code and instructions. I have a data section. Okay, from here to here. In data section I have global variable initialized. Okay, just like previous part. Okay, global initialized variable file, a global variable initialized has been located in that data section. Okay, but in that data section I have my global variable static, global static variable. Okay, in that data section you probably know yourself what is static global variables. Okay, sorry, a variable that is static and defined out of functions. Okay, when you have a static global variable, you can't have just access to this variable just in this source file. Okay, just in that main.c. Okay, you can't have access to this variable, for example, in other source file, for example solar.c. Okay, your compiler puts the static variable in that data section, global static variable. Okay, another variable is constant variable with const keyword. Okay, you have your constant variable in .rodata section. Okay, you have all of your constant variable, local or global, static or unstatic. or automatic. Okay, you have all of your constant variable in .rodata section in your object file. Okay, but zero initialized variable, initialized to zero. You have all of your zero initialized variable, constant, static or non-static or automatic in .bss section. You have all of your zero initialized variable in .bss section. .bss section is related to zero initialized variable. But as you can see, your compiler allocate memory to local variable in your stack frame of your function. Okay, and after returning from your function, you don't have access to your local variable anymore, and your local variable another time a local variable loses its value after returning from a function, okay, from its function. But if you have an static local variable, this variable preserves its value even after returning from your function. Okay, and if another time you come back to your function, the static local variable preserves its value. Okay, so you have your local static variable in that data section, local static variable, okay, in that data section. You don't have these types of variables in your stack frame. Okay, so this type of variable can preserve its value even after returning the function. Okay, if you another time come back to your function, another time call your function, this variable preserves its value, will preserve its value. Okay, so let's to see the symbol table of this object file. Read ELF with -s option and name of object file. As you can see, global initialized variable. Okay, the binding is global and is object data type. But for example, global static variable is in section number 2, that is data section. Okay, in this example, number 2 in this object file related to data section. Okay, is the binding is local. Okay, binding is local because of static keyword. Okay, and it's object. Okay, but we have another types of variable, global uninitialized variable. Okay, you don't have global uninitialized variable in none of these sections. Okay, you can't see your global uninitialized variable in this section. I will talk about uninitialized variable in a few slides ahead. Okay, in next slides. So let's go back to our slides. Variable and section. You have your global initialized variable, global static and local static in that data section. You have all of zero initialized global variable, global static or local static in that BSS, and all of your constant variables in that RO data section. And your linker can use these sections to relocate your variable's address. Okay, your variable's addresses. Okay, in previous part I said that linking stage has 3 main jobs. Okay, symbol resolution, combining object file, and relocation. Now you know what is combining object files and relocation. You know what is the concept of relocation. Okay, but In this part, I want to talk about symbol resolution. But before to talking about symbol resolution, I should talk about uninitialized variable and weak symbols. Okay, uninitialized variable and weak symbols. Let's first to talk about uninitialized variable in a source file. Okay, as you can see in this project, I have an uninitialized variable in my main.c source file, and I have a variable with the same name, global variable, but here is initialized. Okay, I have multiple definition of one variable one time in main.c and another time in solar.c. Okay, but let's to see the value of this variable. As you can see, the value of variable is 10. Okay, let's to zoom that the value of variable is 10, because when you have an uninitialized variable and with the same name an initialized variable, in symbol resolution stage, the initialized variable definition takes the precedence. Okay, and your linker uses this definition in solar.c for linking your project. Okay, so when you have uninitialized variable and an initialized variable with the same name, the initialized variable takes the precedence. Okay, so let's do a stop project, and another time define two initialized variable with the same name. For example, here equal to 20. Okay, if you build your project, your linker throw an error to you, multiple definition of this variable, global variable. You can't have two initialized variable in two object file with the same name. Okay, but you can have one uninitialized variable and an initialized variable. Okay, one or more uninitialized variable and just one initialized variable. Okay, and the initialized variable takes the precedence in linking stage in symbol resolution. But with this command, I can have two initialized variable in two source file with attribute, give an attribute to or symbol. Okay, weak. Okay, I have an weak definition and a strong definition. Okay, here is not weak, so is strong. Let's do build our project. Okay, we have no error. Let's do debug our project. Okay, as you can see, I have two initialized variable. Okay, but one of that is weak, another is strong. So let's to see the value of global variable. As you can see, the value is 10. So the strong variable takes the precedence. Okay, yes, here is difference between weak and strong definition of an symbol. Okay, we can have weak functions just like variables. For example, let's to give you an example. For example, assume that I have a function. The name of my function is solar. Sorry, a void function. The name of function is solar, and I have function with the same name in solar. Okay, but for example, assume that one of that is a weak symbol. Okay, for example, assume that in this function I want to put this value to global variable. For example, global variable equal to 30, but in this function that is a string, the value of global variable is equal to 50. Okay, let's stop my debugging and rebuild my project. As you can see, I have two functions with the same name, but I have no error in my compiling and linking, okay, because one of that is a weak function. Okay, let's do another time debug our project and see the result. Oh, before that, let's do call our function in main. Okay, call our function in the main function and debug our project. Okay, as you can see, in the first step running and the project, the value of global variable is 10. Okay, is 10 here. Okay, because here I have a weak definition and here I have a string definition, so the string definition takes the precedence. But let's do run solar function. I have a solar string definition of this function and a weak definition of this function. Let's do a step into this function. Okay, a step to the string function, because in the symbol resolution stage, in the linking stages, the string definition takes the precedence. Okay, here is difference between a string definition and weak definition. Okay, let's go back to our slides. So you know that an initialized variable with the same name takes the precedence, okay, from an uninitialized variable, okay, and a string takes the precedence from weak symbols. Okay, you can define weak symbols in assembly file with that weak directive. Okay, so what is symbol resolution? To exactly select one definition among all of same name symbols among all of object files. Okay, exactly one definition. For example, initialize takes the precedence from uninitialized, or string definition takes the precedence from weak definition. Okay, to select the one definition is the responsibility of symbol resolution stage. Okay, so now you know what is symbol resolution, what is combining object files, and what is relocation. Okay, here is main jobs of a linker. Okay, so let's talk about common and undefined section in your object file. Okay, these sections are not like other sections, for example .data section or .ro data. Let's see the differences between these sections. Okay, so let's see an example here. Assume that in your source file you have a declaration of a function, for example void solar. Okay, you just have the definition of the function. Okay, and you want to call your function, and in other object file you have the definition. Okay, here just you have the declaration of function, but here in this file you have the definition of the function. Okay, the bodiless function. Let's make my project. Control L, make the project, and let's see the symbol table of my main.o object file. R real with -s and main.o. As you can see, the section of my function is undefined. What's the meaning of undefined section? It means that you just have declared the symbol in your source file and you need to define this symbol in another file. Okay, for example, if you don't have definition and another time make your project, you will have an error in linking stage, undefined reference to Solar. Okay, because in that main.o this symbol is undefined. Okay, or for example, assume sorry, let's uncomment this part. Assume that you have a uninitialized and external variable with external keyword, for example global var, okay, integer. Assume that you have an integer global variable that it's external, okay, but here you have the definition of your variable, for example equal to 10. Save the source files and make the project. Make sorry, I have an error. Oh, sorry. Make the project and another time see the symbol table of my object file. As you can see, sorry, we should use this variable, for example global variable plus plus. Another time save and make the project. Okay, another time see the symbol table. As you can see, I have my global variable as an undefined variable. Undefined variable because of this .extern keyword. When you have an external variable or a function that is just declared and not defined, you will have undefined section in your object file. Undefined section means that you need to define this variable or this symbol or this function in another object file. Okay, here is undefined section in the object file. Application of undefined for external variables and function declared in source file but defined in another source file. Defined in another source file. Okay, but what is common section? Let's to see another example. Okay, here assume that you have an uninitialized variable that is not external. Okay, and here you have the definition of variable. Okay, let's just save the project and make the project. Make and see the symbol table. As you can see, the section of global variable, uninitialized global variable, is common. But let's to see the content of object file with object dump and dash d main.o. Okay, we don't have that common section in my object file. What does mean common section? When you have an uninitialized variable, you have your variable in that common in the common section. Okay, in the common section. It means that uninitialized variable has no specific function. Okay, in this time, if I have another definition of this variable, another initialized definition of this variable in other object files, This definition takes the precedence, and my linker puts my uninitialized variable in .data section. But if I don't have this definition with the same name in another object files and make the project, my linker puts this uninitialized variable in .bss section. Okay, let's to see the linker script. As you can see, in .bss section, I have common section. If you don't have another initialized variable in another object files, your compiler will put your variable in .bss section, and your processor will put a value of 0 in your uninitialized variable. But if you have another initialized variable in other object files, that definition takes the precedence. Okay? An uninitialized variable almost like a weak 0 initialized variable. Okay, but they are not same concept. Okay, so undefined and common are not real section in your object files, but they have some application in linking stage. Okay, let's give you another example about relocation, but in this time function relocation, and give you an example about function relocation. Assume that you have this function and your main function, and you want to call your function in your main function. Okay, here is the assembly file, the assembly instructions in output file, not object file. Okay, because you have real addresses for your instructions. Okay, how can I see this information by GCC? Let's just see that. First, assume that in my main, let's see, I have a function void salar, and I want to call my function in this line. Okay, let's save and make my project, make the project. And how can I see these informations by GCC? By using another time our object dump, but in this time, for example, if you want to see the body of main function, you can use this assemble equal sign and name of your symbol. Okay, from your output file. Okay, you can see the body of your function here. Okay, and for example, see the body of solar function. You can see the body of solar function here. Okay, and after that, let's see the body of object file of main.o with capital V and name of our function. Okay, that's all. As you can see here, I have not relocated sections. Okay, these sections have not been relocated, but in output file I have relocated sections. Okay, I have real addresses for my instructions and my symbols. Okay, but as you can see, the instruction of branch in main in object file is this value fe, but the instruction in the output file is here f6. Okay, so a relocation has been done for this instruction. Okay, changing this value to this value. Here is a function relocation. Okay, let's talk about that more in our slides. Okay, as you can see, I have my output file sections here, and here is instruction of this branching and link instruction. Okay, in output file, it's a relocated form. Okay, in output file. Okay, but how my processor will branch from this instruction to this address by this instruction. Okay, your processor follow this formula to branch to Solar. This address, I say to that PC, or I say that main. Okay, I say that main, jumping from main to Solar. Okay, plus 4 because of pipeline structure of your processor in a Cortex-M processor, plus an immediate value. Okay, this value is equal to this address, Solar symbol. Okay, so this value plus 4 plus immediate value is Solar. Okay, main means BL main. Okay, assume that here is BL main. Okay, BL main, this address, plus 4 plus immediate 32. Immediate 32 is this value, but how can I get this value from instruction? You can get this value and acquire this value by using of the structure of encoded instruction. Okay, let's do open reference manual, architecture reference manual document, and go to the branch and link instruction in this page. Okay, as you can see, you have your encoded instruction. Okay, here is encoded instruction. Sorry, here encoded instruction. Okay, but you can acquire and get the immediate 32 value by using of these formulas in this line. Okay, by using of these formulas, you can acquire this immediate value from encoded instruction. Okay, but this immediate values and these bits. Okay, here is encoded instruction, here is encoded instruction, and here is immediate value. Okay, your processor first get this value from your instruction and use that to calculate the address of this function. Okay, so as I said in previous part, after combining object files, your linker now what is the base address of the sections in your memory. Okay, and other sections. Okay, for example in flash and SRAM. So after combining object files, your linker now the base address of, for example, .text in main.c. Okay, or main.o object file. Okay, but let's talk about function relocation in this example. Before that, let's see the relocation table and symbol table in my object file with that arm read elf-r for see the relocation in main.o file. As you can see, I need to do a function relocation. The type of my relocation is thumb call. Okay, in this offset in my .text section, as you can see in my object file here in this address 10 in hexadecimal. I need to do and relocation. Okay, here is info about my relocation, the type and value to symbol table. Let's see the symbol table. Relocation to number 8. Okay, number 8 here is solar. Okay, relocation to this symbol. Okay, so I have my relocation in try here. I need to do a relocation in the text section in offset 10 in hexadecimal to this symbol 8. Okay, and the type of relocation is this type. Okay, you can see all of types in this. Let's copy the type and see that in ARM ELF. If you search for that, you have this relocation type here. Okay, you have this relocation type here. The number of this type is 10, or A in hexadecimal. Okay, so how your linker do this relocation? First your compiler get this address of solar. Okay, address of solar by using up that text base address from combining object file plus this value 0 equal to address of solar. Okay, after that acquire this address BL main branch and link instruction in your main function. Okay, by using another time the text base plus this offset. Okay, plus equal to main. Now you have main and solar address. Now you need to acquire this immediate value by solar and main from this formula. Okay, so the value of immediate value is solar minus 4 minus this address. Okay, and you can acquire and get this value. Okay, like here. Now you need to modify your instruction with this immediate value. Okay, you need to modify this instruction, this value in your memory by using of immediate value and this formula, these formulas. Okay, and in this way you can acquire and get the relocated instruction. Your linker calculate this value and put that in your object file instead of this value. Relocate that and put that here. Okay, now function relocation for this symbol and this instruction has been done. Okay, this was another example for relocation. Now you see two examples, one for global variable relocation and function relocation. We have other types of relocation, but the concept is identical. The concept in all of these relocations is identical, and you can see and study about other relocation in this standard from ARM. Okay, ELF for ARM architecture. ELF file. Okay, you know that an object file and an executable file is not a dump file, is not an unstructural file. Okay, your object file and your executable file has a complete structure, complete defined structure. Okay, and you can find the structure of your object file and executable file in ELF format. Okay, you can study about ELF object file and executable file format and see the complete structure of object file and executable file. Now you know that your object files, for example, created from sections or other metadata informations. Okay, and your executable file, like object file, create from sections, output sections. Okay, but the concept of linking stage and the responsibility of linking stage is symbol resolution, combining object files, and relocation. These parts, these steps are the main jobs of your linker. Okay, here was some information about linker and global variables and relocation. Okay, enough for today, and enough for description about linker and global variable. And now you know a lot of information about your variables, your local variables and your global variables and linking stage. Okay, thank you very much to see me, and see you soon in the next part. Thank you very much.